Hello everyone, this is Aditya and I wish you all a very happy new year. And I recently came across a pic which states happy and then this expression. So many asked me that what does this expression mean? So in order to explain that, I thought to derive all these expressions, right? So before that, we need to check that what does it actually mean, right? So let's see. We can see that third expression and this expression are somewhat similar, right? We know 1 cube plus 2 cube till n cube is equal to n square into n plus 1 whole square by 4, right? So over here n is equal to 3, right? N is equal to 9, sorry, right? So we have 9 square into 9 plus 1 whole square by 4, which is equal to 81 times 100 by 4, which is equal to 2025. So it basically states happy 2025, means this is the present year, right? Okay. So now I will erase all this and we will see the derivation of all this, right? Okay. And of course, we will not use the mathematical induction, we will use the algebra, right? So let's start with the first one, that is 1 plus 2 plus 3 and so on until n is equal to n times n plus 1 by 2. So to derive this expression using algebra, we are going to assume expression k plus 1 whole square. Just don't worry that why I have assumed, just write it, okay? And it is equal to k square plus 2k plus 1, right? Is it fine? A plus b whole square. So notice that we have k plus 1 whole square minus k square is equal to 2k plus 1, right? Okay. So now what we are going to do is that we are going to put k is equal to 1, right? So we get 1 plus 1 whole square minus 1 square is equal to 2 times 1 plus 1, right? We are getting this. So basically we are getting 2 square minus 1 is equal to 2 times 1 plus 1, right? Okay. Now when you substitute k is equal to 2, you will get 3 square minus 2 square is equal to 2 times 2 plus 1, right? You will get this, okay. And when you substitute 4, I mean 3, you get 4 square minus 3 square is equal to 2 times 3 plus 1, right? And so on till n plus 1 whole square minus n square is equal to 2 times n plus 1, right? You will get this thing, right? Now add all this. This and this gets cancelled, this and this gets cancelled, and this will get cancelled, and n square will also get cancelled. So we are left with this and this expression. Such series is called a telescopic series, right? Okay. So basically we are going to get n plus 1 whole square minus 1 is equal to 2 times 1 plus 2 plus 3 and so on till n plus this will be n, right? Since there are n terms, right? Are you understanding it? You put from k is equal to 1 to k is equal to n. So basically you have n terms, right? So what is this? This is equal to n square plus 2n plus 1 minus 1 is equal to 2 times this sum 1 plus 2 and so on till n plus n. So you get n square plus n by 2 is equal to 1 plus 2 plus 3 and so on till n, right? So you get this expression is equal to n times n plus 1 by 2, hence proof, right? We have proved this one. Now let's move on to the second one. So now let's derive the second expression and let's see how we will prove it. Okay. So likewise we did in the previous case, we had assumed k plus 1 whole square. In this we are going to assume a next degree power, I mean k plus 1 whole cube, right? Okay. So it is equal to k cube plus 3k square plus 3k plus 1, right? Okay, a plus b whole cube, right? So you get k plus 1 whole cube minus k cube is equal to 3k square plus 3k plus 1, right? Now you just substitute k is equal to 1, 2 and 3 and so on. Let's see what we'll get. We get 2 cube minus 1 cube is equal to 3 times 1 square plus 3 times 1, I mean 3 times 1 plus 1, right? Okay. You substitute 2, you get 3 cube minus 2 cube is equal to 3 times 2 square plus 3 times 2 plus 1, right? You get this thing. Okay. When you substitute it equal to 3, you get 4 cube minus 2 minus 3 cube is equal to 3 times 3 cube plus 3 times 3 plus 1 and so on till n plus 1 whole cube minus n cube is equal to 3 times n cube plus, I mean n square, sorry, plus 3 times n plus 1, right? You get this thing. Now just add all these expressions. What you get when you add this and this gets cancelled, and this, and likewise all this. Okay, just like the previous one. Okay, so you get n plus 1 whole cube minus 1 is equal to 3 times 1 square plus till n square plus 3 times 1 plus and so on till n plus how many terms are there? N. So we get n over here. Now we know this expression, we had just prove it right now, right? So this is equal to n cube plus 3n square plus 3n plus 1 minus 1 is equal to 3 times, so let's say it as s2, right? Since it is the power of 2, right? Okay. Plus 3 times, let me write it clearly, 3 times what is this? This is equal to n into n plus 1, n plus 1 by 2 plus n, right? You get this thing. So when you solve, you get n cube plus 3n square plus 3n, right? This is equal to 3s2 plus 3 by 2 into n square plus n, right? When you move n from RHS to LHS, you get n cube plus 3n square plus 2n is equal to 3s2 plus 3 by 2 n square plus 3 by 2 n, and now let's solve it. You get n cube plus you get 3 by 2 n square plus you get n is equal to 3s2, right? And it will be n by 2, right? So we get n cube plus 3 by 2, I mean, let me solve it. It will be equal to 2n cube plus 3n square plus n by 6 is equal to s2, right? And of course, it is very simple to factorize it. And of course, if you don't know, I am telling it, right? So we have 2n cube plus 3n square plus n by 6, right? Okay. So we have 2n cube plus n square plus 2n square plus n, right? We have this expression, right? Now just take n square common this. We have 2n plus 1 plus, you take n common, you get 2n plus 1. So you have 2n plus 1 into n times n plus 1, of course, divided by 6. And this is what which we needed to prove, right? And of course we can do it again and you will get the same result. Okay, so now let's move on to the next part, the last part. Okay, so now let's see this expression, that how do we evaluate this, how do we prove this, right? So let's see. Okay, so again we are assuming k plus 1 to the power 4, right? The power next to it, right? Okay, and this is equal to k to the power 4 plus, and of course if you don't know the binomial theorem, then you can evaluate also, it's no issue. K plus 1 raised to the power 4 is equal to k square, or maybe you can do it like this, k square plus 2k plus 1 whole square into k square plus 2k plus 1, right? Of course if you don't know the binomial theorem, you can use like this, right? You can use just the multiplication, right? Okay, so you get k to the power 4 plus 2k to the power 3 plus k square plus 2k cube plus 4k square plus 2k plus k square plus 2k plus 1, right? So you get k to the power 4 plus this and this expression 4k cube plus k square plus 6k square plus 2k and 2k 4k plus 1, right? So you get this thing plus 6k square plus 4k plus 1, right? Okay, now we will just substitute the values and we will get the result. Okay, so but before that, k plus 1 to the power 4 minus k to the power 4 is equal to 4k cube plus 6k square plus 4k plus 1, right? Now let me erase this and then we will see this one. So now let's see for k is equal to 1, what we get. 1 plus 1 to the power 4 minus 1 to the power 4 is equal to 4 times 1 cube plus 6 times 1 square plus 4 times 1 plus 1, right? And you substitute 2, you get 2 plus 1 whole to the power 4 minus 1 to the power minus 2 to the power 4 is equal to 4 times 2 cube plus 6 times 2 square plus 4 times 2 plus 1. And when you substitute 3, you get 4 to the power 4 minus 3 to the power 4 is equal to 4 times 3 cube plus 6 times 3 whole square plus 4 times 3 plus 1, and so on and so forth till n plus 1 to the power 4 minus n to the power 4 is equal to 4 times n to the power 3 plus 6 times n to the power 2 plus 4 times n plus 1, right? Now just add all this expression. What you get? This is 1, right? Of course, again it is a telescopic series. You get n to the power n plus 1 to the power 4 minus 1 is equal to 4 times, of course this is 1 cube plus, so I write it as 3 plus 6 times s2 plus 4 times s1 plus n, right? And when you open it, you get from this, right, you get this thing, n to the power 4 plus 4 n cube plus this expression minus 1 is equal to 4s3 plus 6s2 plus 4s1 plus n, right? Okay, now you can just evaluate it. It is n to the power 4 plus, you have n over here also, so you can cancel it. So you get 4n cube plus 6n square plus 3n is equal to 4s3 plus 6 times n into n plus 1 into 2n plus 1 by 6 plus 4 times n into n plus 1 by 2, right? You get this? Okay. And let's solve it. N to the power 4 plus 4n cube plus 6n square plus 3n is equal to 4s3 plus, and when you solve it you will get let's see, n square plus n into 2n plus 1 plus 2 times n square plus n, right? You get this thing. Okay, so you have n to the power 4 plus 4n cube plus 6n square plus 3n is equal to 4s3 plus, let's evaluate this one. Of course you can take n square plus n common, but I'm not doing it. Okay, so you get 2n cube plus n square plus 2n square plus n plus 2n square plus n, right? Okay, and of course it will be equal to 2n, and when you add all this you get n to the power 4 plus 4n cube plus 6n square plus 3n is equal to 4s3 plus 2 times n cube plus, just solve it, you will get 5n square plus 3n, right? So you get 4s3 is equal to, bring all that to the LHS, right? So you get n to the power 4 plus 2n cube plus n square, right? If you solve it, so you get s3 is equal to, take n square common, n square plus 2n plus 1, right, divided by 4, and it is equal to, right, hence proved. And one thing to be noted over here is that this s3 is also equal to n into n plus 1 by 2 whole square, which proves that 1 cube plus 2 cube till n cube is equal to 1 plus 2 plus 3 and so on till n whole square, right? Which means you can also write it as happy 1 plus 2 plus 3 and so on till 9 whole square, right? So I hope that you understood everything, and if you all enjoyed the video, then please do like and subscribe my channel, and bye bye, take care.